Tomorrow you don't have a class for your batch, afternoon batches. Okay. If possible, next week is a holidays, so you see.
Sir, what about Sunday?
Sunday also no class this Sunday. So far we discussed, guys, what is the network, networking, internetworking concepts. Okay, so where is this? I put a one picture here, something it is happened to this. Here, no one can edit, right? So what happened? Yeah, it's not that one. Sorry, cable. End. So whatever I put here, so this has become randomly pictures are changed. Okay. So this picture is not here. Why this picture came to multiple places? So we discuss about again it is came.
Hello, sir.
Yeah, tell me.
Sir, Saim Taslim present, sir.
Which one?
Saim Taslim.
Yeah, present.
Okay, thank you so much.
See, this is a short system configuration. There is a, I think, till yesterday it is good. So, right. Maybe because of this footnote concept. Now see, the pictures are deleted. See? That picture is pasted at foot, like a header and foot is there now. Picture is pasted there. That is should be there. Somewhere in the adjustment, it is went to that page. Okay. So in networking, guys, we discussed about what is networking concept and cables. We discuss LAN, WAN kind of stuff. We discuss hubs, switches, routers, modems. These are all we discuss. So first of all, we'll see topologies. Topologies is a small concept. Okay. And OSA layers and IP addresses, and one or two points are there. We'll see that one. First one, we'll finish this topology concept. So today is the 6th, 01/20/23. This is your daily notes tracker, guys. I hope everybody still having this link. If you are missing this link because of your WhatsApp having so many messages, okay, If you are missing these links, I will share it again. Okay.
So please share notes.
Better to share once.
So notes. Class.
Something it is happened to it. Okay, I will share it in a minute. Okay, so now we are going to see the topologies. Topologies are two topologies are there, guys. Generally, topology means our mind will go to the physical topologies only. Okay, so what is the physical topology? It is the way of you are connecting devices. The way you connecting a devices. Okay, that is a physical topology. Logical topology is based on how you configure a IP address, like a IP address networking. IP address network. Okay, network is a word, that's it only. Okay, so not just only connection. So like a IP network. IP network means it is if you have 100 computers, out of 100 computers, only 10 computers will communicate each other. All 100 are connected, but only 10 can be able to communicate because of their IP network is different. That kind of stuff also is there. Okay, that's why it is logical topology depends upon how you configure IP address. Physical topology, this is depends upon how you connecting a devices. In a physical topologies, different type of physical topologies are there. Main physical topologies are bus topology, ring topology, mesh topology, star topology, hybrid topologies, and some other topologies also available like a bus topology, point to point topology, point to multi-point topology, hybrid topologies. These are the topologies. So, in general, it's difficult to draw, but actually one drawing picture is there, so I can copy paste, but I need to explain, right? So that's why I'm drawing again.
Sir, we need to make notes.
If you want to write a notes parallelly, so that is also good. Or you want to see a recording, first of all you listen now. Later you want to prepare a notes from the recordings, also you can do it. Okay. Important is you have to practice answering, guys. Take everything as a question and practice.
Okay, sir.
I told about physical topologies, different physical topologies. Now open a blank page like this. Okay. So then what are the physical topologies? Bus topology, ring topology, mesh topology, star topology, like that. Something is happened to this link. Why it is become offline kind of stuff? This is working. It's become offline. Entire Google Docs is in offline. No, something has happened to this. It's okay. Because even I want to insert, I can't able to try anything. Okay, now problem just I will tell here. Guys, look at. Okay, so this is a device like this. We have a devices. Okay, we have a devices, and then I put a name like a. This is my PC, A PC, B PC, C PC, and DPs. So I have a one wire. This is a backbone wire. Okay, this is a backbone wire. I connected the devices to this backbone wire like this. Okay. It is a very easy to configure network it is. So this is a called a bus topology. This topology we are calling it as a bus topology. Bus topology. What is a bus topology? The devices are connected to a backbone wire. So data is transmitting through this backbone wire. So you want to communicate it to B or C or D. So they have to send packets to this backbone wire only. Next, if something goes wrong, like this wire is broken, like this, some backbone have got a problem. So what happened? Further communication will stop. Means AB will communicate, but A cannot communicate it to C or a D. Okay, it is very simple to configure, easy to configure, but difficult to troubleshoot, and it is not much redundancy type. Because of any wire, the backbone wire is somewhere it is down or some cutting is happened, so further communication is become difficult. So this is about your bus topology. Next, I have a devices. So as in a ring topology, problem is everything is connected to backbone wire. If backbone wire got a problem at certain place, further communication stops. So it is has to travel like this in the one single wire only. Every data is travel through the backbone wire only. Now what I have done, so I have a different PCs like a PCA, PCB, PCD, PCE. Okay. So one device is connected to another device, other device is connected to another device like that. So one device is connected to all, next device. And finally, the last device is connected to the first device. So it is form a ring. This topology we call it as a ring topology. This topology we call it as a ring topology. Of course, this is also easy to connecting, but difficult to configure. Little difficult to configuration is there. If we have to go to each and every device and tell how they should communicate. For example, you want to communicate from A to D. It is A to D communication. How it will communicate? Packets sent to B, B to C, and C to D. Now D want to communicate A. How it will communicate? D to E, E to A. So it means either it is clockwise or anti-clockwise, it will communicate. Depends upon the configuration. Next one is if in case CPC is down, what happened to communication? A to B will done, but no further communication. D to E communicate, E to A communicate, A like this it will communicate, but this further communication is down.
Yes, sir.
Okay, Shiva Kumar came, but your internet connection down.
Shivam Kumar sir. Sir,
Are you able to
tomorrow
hear
we
the voice, guys?
Yes, sir.
Okay, good. Shivam Kumar present, right? So I will make it. I don't know why this suddenly Google and as well as a Microsoft both are not working. Let me check my speed test. Something, there is a column. Even searching is also not working. It is showing internet is working. So I will make it because it is showing you are not connected to internet. I don't
Sir,
know.
mine also, please. Brijan Singh.
Which one name?
Brijan Singh.
Okay, okay. Shivam Kumar and Vijay Singh. Guys, this is what happen if one of the wire is down, further communication will stop. If any device in down, further communication will stop. Okay. To avoid these confusions and lengthy communication, what they done, so they added a one more line. So one side it will work as a clockwise, other side is anti-clockwise. Means A to D communication will happen AED. Okay, like that only. It's simple, like a D to A communication, DEA. So this much not required. Even if any device is down, still no problem. Other path is there to communicate. But still, it is difficult to scalable. Scalability means ability to increase the infrastructure, ability to increase. Okay, like you want to add one more device, then again you have to reconfigure entire devices for how they should communicate each other. Okay, so this is difficult to scalable, difficult to troubleshoot. Okay, this is the one kind of ring topology. Generally, we don't use bus and ring. Generally, we don't use ring topology at all. Okay, it is there earlier. Next topology. Okay, Abhishek Giri also present. It is still showing internet is not connecting. Okay, so to make it smaller, I'm trying. Okay. Anyone guess which topology it is?
Mesh topology.
Very good. It is a mesh topology, guys. When you see like this, immediately people will tell it is a star topology. Now, guys, it is a mesh topology. What I'm trying to say. What is a mesh
Where
topology?
one device.
Yeah. Every device is connected to all other devices. Every device is connected to all other devices. Every device is connected to all other devices. So it is a highly redundant device. Sorry, a highly redundant topology. It is a complex. First of all, it is a complex. because we have to connect every device to all other devices. Lot of wiring is required and lot of connectivity is there. So it is a complex topology, but redundant. What is the meaning of this redundant, guys? If BPC is down, no problem. A, B, C, D, sorry, A, C, D, E will communicate each other. B is not communicating. That's it. For example, a wire is broken like this wire is disconnected. A to B communication is stopped, but B to E to B, D to E, C to E's communication is there. It is a complex to design a mesh topology and it is difficult to troubleshoot, but it is redundant. Why redundant? If any device or a wire is down, still we can able to communicate with other devices and other paths. That is a mesh topology. And also we are not using a mesh topology in general cases. Like, okay. So mesh topology also using in the only cases is like where highly redundancy is required, like a servers, rooms, SAN storages, core networking side means there if one router is down, no problem, other routers will do all other communication. So continuation is there. Okay. So like that. So when we are using a SAN storages, so one SAN server is down, but other server is there to do the work. So one way or other way, everyone is connected each other. And it is very difficult to scalable. Why it is difficult to scalability? Look at here. Again, if I add one more device, again, each device need a one more NIC have to insert. Again, you have to connect it like this. Drawing is easy, but so think like this. You have already 50 PCs are connected. Now you got a 51 PC. Then you have to go to each and every device. You have to close the device, add one more NIC, again one more cabling. And because of limited port connectivity, also we cannot create large number of devices into single network. 5 devices, 10 devices are okay. Not 50 devices, 100 devices. You cannot connect each other like in a mesh topology. Okay, because every PC having a
Hi,
limited port numbers, limited
highly
NICs.
cost.
Tell me.
Sir, there is high cost in mesh topology.
మీరు తీసుకొని ఇల్లు మీకు చేస్తా
No, problem.
మీకు చేస్తా 10 నిమిషాల్లో చూసారు
Okay, I didn't get so no. So next one is there, guys. This is a centralized device. Think like it is a search, and there is other devices like this. So devices means like a computers are connected to a centralized device. The centralized device can be a hub or a switch. A centralized device can be a hub or a switch. It can be a hub or a switch. So devices, it is a very simple to configure. A, B, C, D, APC, BPC, CPC, DPC, EPC, FPC are like that simple. Devices are connected to a centralized device, either it can be a hub or a switch. All are communicating through this switch or a hub only. Like A to communicated to B. A send a packet to the hub or a switch and it will send a packet to B. Okay, all communications through this centralized device only. It is very simple to configure and simple to troubleshoot and easy to scalable. And it is easy to scalable. This topology we call it as a star topology. This topology we call it as a star topology. What is the scalability? Think like this. I have a multiple devices or need to connect in a network. For example, in my office, I have a 50 computers are there, maybe 100 computers are there. So several computers are connected. So switch or a hub having a limited port numbers, right? Switch or a hub having a limited port numbers for each switch. For example, you take a 24 pin port switch. So 24 port switch means 24 connections you can make it. But I have a 50 computers or 100 computers are there. Okay. So how to connect those things? We are connecting like this. Next one is we will connect like this. So what is this meaning? This is the extended star topology. It is a scalable. Star topology is easy to scale, easy to configure, easy to troubleshoot, and no redundancy. So why no redundancy? I'll show you that one. First one, easy one, means positive one. For example, C device is down. Only C won't communicate, but remaining devices will communicate each other. For example, this line is down. Only this device we can't communicate, but remaining devices will communicate. Okay, but if in case this hub or a switch is down, no communication. But still, it is easy to troubleshoot. If any issue is there because of this switch and hub, will tell you what is going, which one is connected, not connected, kind of stuff. We can easily understand. Compared to bus topology, ring topology, and mesh topology, in the three topologies, we are not using any additional device to connect. We are using only cables. In bus topology, we are using backbone cables, and the remaining ring and mesh topologies, we are using direct cables only. Okay, but in a star topology, not only a cables, also we are using a switch or a hub kind of devices. And if you scale this one, so then we can able to add multiple devices. We are all using a star topology only. We are all using star topology only. Okay. Point-to-point topology. What is point-to-point topology? If you are two devices are connected directly, for example, if you see ring topology or mesh topology or a star topology, there are all point-to-point topology. Means two devices are connected like one to another one. That is a star topology. Any device to any device. These two are direct star point-to-point also using. This is point to multi-point kind of concept. Means one switch is connected to multiple devices. Guys, this concept actually in the routers concept. Two routers are there. For example, they are connected one to another one. This is called also a point-to-point topology. For example, this is a router 1 and this is router 2 connected directly. Okay. So this concept, it is point to point. Point to multi-point connection is also there. For example, you have a router and you have a multiple router. Means one is connected to multiple things. Like this is connected to this, and this is also connected to this. This is a point to multi-point topologies. Hybrid topology means combination of one topology to another topologies. So I didn't give in a note kind of stuff, but okay, one more topology there, guys. That is a tree topology. So recently, people are asking me, so what is a tree topology? Explain. So it is having a backbone wire. Can you see? This is a backbone wire is there. So all these devices are different topologies are connected to a one single backbone topology. Okay, it's also a mesh. We'll make it small. Okay, so this is a tree topology. Remaining topologies you can view from here. So these are your physical topology, guys. Okay, so that's a point. So next one, so you have a notes here. You can try to read it from these PPTs. I think so. Now this is working. Shaik came. Vijendra came. Mayank Yadav came. Muhammad Shah. Ram Govind. Ravi Yadav. Tom Kumar came. I remember 3 names are given. Guys, up to here. Before going to next, guys, I want to tell few small things for adding to this. Connected, not connected. Are you able to hear?
Yes, sir.
Yes, sir.
So I'm
Yes, sir.
asking. So
Yes, sir.
next one is while we are communicating from one device to another device, it can be a simplex type or a duplex, off duplex, or a full duplex. Okay, it can be a simplex. Simplex means you are it is a one-way traffic. Either you send or receive a things. Means you are sending, other side receiving. There is a sender, receiver. Source send, destination receive. Only one-way traffic. One line, and you are sending, other side receiving. That's it. Off duplex. Off duplex is it's a one single line again. As a simplex only it is, but off duplex. When you are sending, other side receiving. When other side is sending, you will receive. So you do send and receive, but not at same time. Example, walkie talkie. So Generally, Walkie Talkie will keep receiving commands from centrally. If you want to talk, then there is a button, you have to press the button, then only you can able to talk. Okay, and you have to tell every time end of the message kind of stuff. Okay, like Roger that, copy that, okay, like that. So you have to tell. That is off duplex communication. It's a two-way communication. Next one is full
Sir,
duplex
what is
communication. Tell me.
the example of simplex?
Simplex device example. So one-way communication, that's it. Okay, it's not. Simplex, like you talk, other people listen. Like you have a mic, that's it. You don't have a speaker. Other person having a mic. Other person having
phone, like like a radio.
like a radio. Of course, even it is a broadcast, it is like a radio. So radio from radio station, they are speaking, they are playing songs, we are listening. So that is also good. Next one is
Yes,
full
sir.
duplex. Full duplex is two ways communication. Half duplex is also a two-way communication. But in half duplex, it's a single line. Either you send or receive. Okay. But in a full duplex, it is not like that. Full duplex is actually two-way communication with two simplexes. Means when you send, other person receive in one line, in another line they will send and you will receive. Okay, so you will do send and receive at a time. Now duplex you cannot do send and receive at a time. Full duplex, there is no full duplex, actually it is a two simplexes. Okay, so send and receive only. So you can send and you can receive at a time. Telephone, like you have a mic and speakers, you can speak and also you can able to listen at a time. Okay, this is one point. Next one is unicast, broadcast, multicast kind of stuff. Okay. Unicast, multicast kind of stuff. Okay. What is unicast? Unicast is one-to-one communication. It's not like it's not belongs to simplex and all. Unicast means we are talking to a person, right? So there is a you are A and there is a B, C, D, E is there. So you are telling, you are sending message to A. So you are telling to address is B. From A and to B. Okay, that is simplex, unicast, one-to-one. Like you are talking to someone, like you are pick a name. So first example, Divyanshi is there. Divyanshi, ask a question. Divyanshi, what is Unicast? So it means I am telling with a name. I'm asking with a certain address. So that is called a Unicast. One-to-one communication. Next one is multicast, one-to-many communication. It's like a WhatsApp group type only. Means think like this. There is a devices like A device, B device, C device, D device, E device. Okay. So A has address, B has address, C has address, D has address, E has address. But all are working on some 10 protocol. Then if A send a packet to a certain address, some address. So that is address means that is everyone. Like you forward a message in your WhatsApp group, then what happen? The group members will get that message, right? Similarly, okay, same communication is multicast. So multicast addressing is means there's a one address for multiple devices based on their protocol and services use. Like I want to install an operating system in 10 computers. Okay, from one server to 10 computers, I want to install a operating system through network. So how it is works? It transmits data to the 10 devices using two addresses, some multicast address. Okay, it is used by certain protocols or services, and including routing management also it is used. Broadcast to all, broadcast to everyone. So it is not a proper any destination. Those who are connected send to everyone. Those who are connected, so send to everyone. Broadcast. No specific destination is there. Anycast is based on the protocol enable. So Anycast is used by IPv6 actually. IPv6. Okay. So if device enabled with IPv6 protocol, then a device otherwise we can say a device send Unicast message like a broadcast. A broadcast is sending a Anycast message, so it will received to only IPv6 enabled devices. So what it is? That kind of stuff. So a device is sending a message only to IPv6 enabling is there or not. So here is I put a one diagram. So look at here. This device, I have 4 devices. So they will
What is
broadcast like. Yeah, tell me.
what is
So what is the
IPv6?
example?
IPv4, IPv6, both are IP addresses. General, okay, both are IP addresses, IP different versions. IPv4 version 4, IPv6 version 6. That's it. I will tell when we are going to IP addresses, then we can go that. There's
Sir, I
someone
didn't
asking.
understand any cast.
No problem, no problem.
So what is the example of broadcast?
Broadcast. Yeah. Broadcast, Anycast. Look at here, guys. I have 4 devices. This device having IPv4 and IPv6. Both protocols are enabled. This is only IPv4. This is only IPv6. This is IPv4 and IPv6. Okay. Now there is a device sending a broadcast message. Broadcast means to everyone. So who can able to receive? All these devices are connected. So all connected devices received. Whether broadcast is a IPv4, IPv6 broadcast, okay, the packet is will be received by everyone. Okay, to every device the packet will go. Anycast means I have some server or a device send a Anycast message, IPv6 Anycast message. So where IPv6 is there, only that devices will receive. Where IPv6 is there, only that device will receive. So it is IPv6 is there, IPv6 is there here, IPv6 is. So these three devices will receive. This device don't receive any Anycast message. Okay.
So what is the major difference between multicast and broadcast?
Yeah, multicast, it is a specific devices or a specific protocol enabled devices are there. It means like a particular type of communication or particular type of service. In that one, it do multicasting, not to everyone. Okay.
Yes, I got it.
Okay. As last in this particular part, not particular part, it is. Yeah, that is enough. Actually, commands are there. So we'll see the commands part also. These are the commands, network commands we use in the networking. Already explained what is ping and a trace RT, and also you know IP config and IP config all. Okay, next time I will tell ARP also. So I will give you a list of commands when times comes, then one by one also I will explain, or all together also I will try to explain. So that's it. Um, Next one I will going to discuss about a OSA model, at least some brief OSA model I will tell. Okay, and IP addresses, both we will discuss. So basic OSA model I will discuss. So take a small break guys, take a 10 minutes.